Hi, this is Biweekly contest 91. Let's start with first question. Number of distinct averages. You are given a zero-indexed integer array nums of even length. As long as nums is not empty, you must repeatedly find the minimum number in nums and remove it. Find the maximum number in nums and remove it. Calculate the average of the two removed numbers. The average of two numbers a and b is a plus b divided by 2. For example, the average of 2 and 3 is 2 plus 3 divided by 2 equals 2.5. Return the number of distinct average calculated using the above process. Note that when there is a tie for minimum or maximum number, any can be removed. So if we have this array, first of all we need to find the minimum, which is 0, and the maximum, which is 5. We calculate the average of these two numbers. 0 and 5, 0 plus 5 divided by 2, the average is 2.5. Then these two numbers executed and the remaining array is like this. The minimum is 1 of this array, the maximum is 4. So the next iteration we will calculate for 1 and 4. And after we do that, the array remains is 4 and 3. We take these two elements and calculate the average, which is 3.5. Notice that we need only to take the distinct average. So here we have 3.5, 2.5, 2.5. There is duplicate here, so we have only two different numbers. To solve this easy question, it's good if we sort the array first, and after we sort the array, so let's say we have array 4 1 4 0 3 5. After sorting, it will be 0 1 3 4 4 5. So then we loop over the array. First of all, we take these two indexes at the border, then these two, then these two, and for each two we push the average result into a set, so that duplicates will be removed, and at the end we return the size of the set. So here we sorted the array, and we loop over the elements and insert the averages. Then we return the size of the set. Okay, let's move to the second question. Count ways to build good strings. Giving the integer 0, 1, low and high, we can construct a string by starting with an empty string, and then at each step perform either of the following: append the character 0 0 times, append the character 1 time. This can be performed any number of times. A good string is a string constructed by the above process, having length between low and high inclusive. Return the number of different good strings that can be constructed satisfying these properties. Since the answer can be large, return a module. So this is here we have these constraints, low and high less than 10 to the power 5, 0, 1 less than or equal to low. Assume we have this example 3301, the output will be 8. One possible valid mode string is 011. So let's copy this. Or let's take this example because so here we have low equal 2, high equal 3, 0 equal 1, 1 equal 2. At the beginning the string is empty and we have two possibilities. Either we push 1 0 because 0 value is 1, or we push 2 1s as we can see here because 1 value equal 2. Then for this string 0 we have two possibilities. Either again we push 2 1s or 1 0. For this string we have two possibility, push 1 0 or 2 1s. But also remember that the length of the array or the string, so the number of the element should not exceed 3 and at minimum should be 2. So here 0 1 1 0 0 1 1 we can push only 0, because if we do 1 1 and we push 2 1s, the length is 4. This is invalid. And for this string we can't do anything. For this one we can push only 0, and for this thing it's the length is 3 already. So here we have 1 1 0, and we have this string, we have this string of length 2, we have this string, we have this string, we have this string, so the total number is 5. Because you are seeing here things is going exponential, so we are going to fix this using dynamic programming. Initially, so we have a table of size high plus 1, and initially TB of 1 y1, because it's the length of 0, so TB of 0 here equal 1, and that means that there is initially one string which is the length of 0. Then we have TP of 2, 2 is the value of 1, TP of 1 also equal 1. It means that there is another string that has the value with the length, or has the length equal to these two characters, which is 1 1. So here we added these elements to this item. We do plus equal because maybe 0 and 1 are equal, so we will have two different strings for this index. Then we will loop over all the elements in from 1 to the table dot size, and for each iteration we check if I minus 0, 0 is the length of this small string, we push. If 1 minus 0 greater than 0, then TP of I equal TP of I plus TB of I minus 0, and if I minus 1 greater than equal 0, TB of I equals TB of I plus TB of I minus 1. What does that mean? Assume so if we have a string, this index of string 0, 1, 2, 3, 4, 5, 6, and we are calculating for this index, we are saying the number of strings on this index equal to 1, or to the current value of which is stored here, plus let's say we have one value equal to, it means that we can add 2 ones, so the value of the table stored here equal to the value stored at this location, which is 5 minus 2. So we added the value stored here to the value stored here, and we do this also for zeros, and so every item at the end will have the number of strings with this length. So this is length 5, and at the end here we will loop over the items from low, our smaller limit, and the higher limit, and we do the summation, and that will be our answer. Alright, let's move to the third question. Most profitable path in a tree. There is an undirected tree with n nodes labeled from 0 to n minus 1, rooted at node 0. You are given a 2D integer array, edges of length n minus 1, where edges of I equal a of I, b of I indicates that there is an edge between node AI and BI in the tree. At every node I there is a gate. You are also given an array of even integers amount, where amount of I represents the price needed to be open to the gate at node I if amount of I is negative, or the cash reward obtained on opening the gate at node I otherwise. The game goes on as follows. Initially Alice is at node 0 and Bob is at node Bob. At every second Alice and Bob each move to an adjacent node. Alice moves towards some leaf node while Bob moves towards node 0. For every node along their path, Alice and Bob either spend money to open the gate at that node or accept the reward. Note that if the gate is already open, no price will be required, nor will there be any cash reward. If Alice and Bob each the node simultaneously, they share the price reward for opening the gate there. In other words, if the price to open the gate is C, then both Alice and Bob pays C divided by 2 each. Similarly, if the reward at the gate is C, both of them receive C divided by 2. If Alice reaches a leaf node, she stops moving. Similarly, if Bob reaches node 0, he stops moving. Note that these events are independent of each other. Return the maximum net income Alice can have if she travels towards the optimal leaf node. Alright, so the question is, let's say we have this tree, and for every node we have an index 0, 1, 2, 3, 4, and there is a value here. This value supplied in the amount array. So for index 0 it's -2, for index 1 it's 4, for index 2 is 2, for 3 -4, for 4 is 6. So Alex will start from the root node, and Bob will start from Bob node, which is at this case 3. So at the same time they will Alice will go to the leaf node, and Bob will go to the root node. So we need to calculate the maximum amount that Alice can gain when she move from this root node to a leaf node. So for example, Alice can go from 0, 1, 2, 2. She should stop at the leaf node, or she can go 0, 1, 3, 4. But Bob can only go from 3 to 1 to 0. He can only go towards the root node. And the rule is, let's say Alex start here, and so she gain or -2, or this is kind of loss. And if she come to this node, she will gain 4. But remember also, if Alex and Bob meet at the same node, so the value of this node, which is 4, will be divided equally between of them. And also, let's say Bob start here, so the first second Alice will move to this, and Bob will move to this. Then Alice move to this, but this one is already opened, so the value -4 will not be considered. So every visited node value will be equal to 0, and if they meet on the same node, the value will be divided by 2. So we need to find the maximum possible gain for Alice. She can come from this way, she can come from this way. In order to fix or to solve this problem, first of all we need to check this path for Bob, which is 3, 1, 0. So we have to implement a function that can return the only path that Bob can pass to. And we can, after that, so we have 3 nodes, and it's guaranteed that for the first half of the nodes, which is this one, after Bob visiting it, so the value will be reset because the gates will be open. So we can set this amount of the value 3 to 0, and if the number of the nodes for this path is odd, like this example, we guaranteed that if Alice and Bob will meet at this point, so we can update the amount to the value 4 divided by 2. So after we calculated we updated these value, then we need to traverse all the possible paths that Alice can go, and we calculate the maximum number. Here are the question constraints: the number of nodes less than equal to the power 10 to the power 5, edges.length equal to n minus 1. Remember, we have the indexes 0, 1, 2, 3, unique integer from 0 to n to n minus 1. And amount of I is an even integer in the range minus 10 to the power 5 to 10 to the power 5 to 10 to the power 4. Okay, so as we said, let's first of all here we can build our graph from the edges so that it will be easy to traverse through the tree. So the graph size, of course, is the number of nodes in, which is edges.size plus 1, because here edges.length equal n minus 1, n equal the number of nodes. So we calculate the number of nodes by adding 1 to the number of edges, and here is our graph. It will be of size n, and for every element it will be like adjacent list of items for the neighbors. So if we have 0, 1 edge, we need to append 0 to as a neighbor to the 1, and 1 as a neighbor to 0. As we said, first of all, we need to calculate the number of or the path item, the path entry for pop to go from pop node to the root. And to do that, we have this function path to pop. We pass it the graph, the current node. The current node initially will be pop. So here we have path to pop, we have the graph, then we need to we start from node 0. So in order to know the path from pop to the root, we can start from this node, and we traverse. At the moment we found pop path, pop nodes. It means all the entries in this path are part of pop paths. This is why here we passed the root node, which is 0, and we tell the function what is the endpoint, which is pop, and this is the vector we need to fill the elements with, and fizz is the visited array to make sure if we visit a node we don't go back and visit it. Alright, if visited of node, if node is visited, return false. Otherwise tag the node as visited. Now if a node equal pop, we need to push first the pop value, and we return true. It means that we arrive to pop node. Other than this, we need to traverse for all possible childs for this node. This is why we have to loop over all the neighbors. So if we are here, we need to visit this until we find where is Bob. If the return value for or the results from this path to Bob is true, it means that this node leads to the Bob node, so we need to push this node. And at the end we have all the nodes that leads from the root node to Bob node. Now by this we calculated this path. After that we need to update the values in Bob path. As we said, Bob will move from here to here, so half of the path will set to 0, and where it meets with Alice we should divide this by 2. So for integer I equals 0 until half of the length of path to Bob, we set the amount to 0. And if the number of nodes from the root to Bob is odd, in the middle where Alice and Bob, we divided the value in the amount array by 2. Now we fill the visited array to false to reuse it again in the second function. Now it's safe for Alice to start traveling from the root node and check all the path to the leaf node. And this is why we use depth first search algorithm. Again we pass it the graph, the amount array, the current node. Initially we start from 0, visit it so that we avoid visited the same node again and again. And here result is passed by reference that will store the final result. Here initially it's equal to integer minimum. Integer sum, it will do the summation for along this path. So if we travel from here to here to here, it will do -2. Remember we divided this by 2, so -2 plus 2 plus 2. And if travel to this path, it will do -2 plus 2. This one is 0, this is 6. So contain the summation for the values of the amount among this path. As we see here, sum plus equal amount of node, and we need to check if this node is leaf. We can know that by checking all the neighbors, that all the neighbors are visited. That means that the leaf is this is leaf node. Other than this, it's not the leaf node. So we loop over all the neighbor of the node and traverse them again. If this is the leaf node, it means that we can check the summation. If it's maximum than the result, then we update the result by this summation. Alright, let's move to the last question. Split message based on limit. You are given a string message and a positive integer limit. You must split message into one or more parts based on limit. Each resulting part should have the suffix, this suffix, where P is to be replaced with the total number of parts and A is to be replaced with the index of the part starting from 1 and going up to B. Additionally, the length of each resulting part, including its suffix, should be equal to limit except for last part whose length can be at most limit. The resulting bars should be formed such that when their suffixes are removed and they are all concatenated in order, they should be equal to message. Also, the result should contain as few parts as possible. Return the parts message would be split into as an array of strings. If it is possible to split the message as required, return an empty. If it's impossible to split, return an empty array. So assume we have this array or this string and the limit equal to 9. It means we need to split this string into a number of entries. In this case it's 14 entries. This is why we use 14, because the number of strings in this array, the number of parts is 14, and in each part we have also to add the index 1, 2, 3, 4 until 14 along with these notations plus part of the string. So here we have 3 letters from the first string, then we have space and is. So we have 3 letters, then we have s and space and I here. What it matters is the number of characters in each string should be equal to the limit, which is 9. So here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, and we have here also 9. The only exception can be the last part. It can be less than 9. So here if we have 1 character it will be okay. Here we have the constraint message length is less than 10 to the power 4, also the limit. The message consists only of lowercase English letters and spaces. So to solve this problem, we need to know what is the possible. Like if we do summation among all of these, the length of each of these array or each of these strings, what will be the total number of characters. So for example, here we have this string and we have limit equal 9, and this string length is 37. So we have 37 character plus 3 multiplied by some value x. So we have 1, 2, 3 characters always exist on every part on the array strings, which are these 3 characters. X will represent the number of elements in this array, in this case 1 to 14. So the number is this one, which is 14. So we have 37 plus 3 multiplied by the number of elements in the array plus number of digits in x multiplied by x, because in every string we have this number 14, 14, 14. So we need so the total number of the 14 characters in the whole string will be 2 here. In this case, the length of or the number of characters in 14 multiplied by how many times it occurs here, which is 14. So here we have number of digit in x, which is x equal 14 in this case, but we need to calculate it. So we have number of digit in x multiplied by how many times x occurred, which is x itself, plus we need the total number of digits. The total number of digits is this digit 1 2 3 4 until all the elements 11 12 13 14, and so this will represent our total number of characters for the whole array. And if we divided this limit, if the total number of the character in the array by the limit, and we found that is equal to x, this means that this is a good candidate, or this solution is valid. So in our implementation here, first we define the length of the message, then we have number of parts, which is x in this case, then we have total number of digit, this one, total number of digit in all the array strings. Then we will loop from I equal 1 to the message length, and for each I we will calculate the number of digits, which equal, we will convert this I to string, and the length of this will be the number of digits for I, and we added this to the total number of digits so far. Then we calculate this equation, so our equation, the total number of digits divided by the limit, as we said, and we take the seal here because the last element, it's possible to have it less than the limit size. So if this value equal to I, this means that I is good or valid answer, so we have to break. After that, we know the I, and which is the number of parts, in this case it's x here, which is 14 in our example. After we know this, we need to start splitting or formatting our array of strings like the result. So we need to loop from 1 to the number of parts. For each string, we start creating this string s, and we have index where we move over the original message itself, so this index should be less than the message length. And remember also this string s that we format, s will represent each item in this array, this one or this one or this one, and the size of this s should be less than limit. So we push the messages indexes, and we push the notation here, less than equal string and the number, the index, which is 1 2 3 4, and here we have the number of parts plus this, and we push the result, the string, to our vector of string, and we return the result at the end.